All here?
Yes.
Okay. So we say there is these three views are the most common to be used to reflect or to represent a product. So which is the front view, top view, and right side view. But some of the product or some of the objects are more complex. So and they have a lot of interior features. That means some part is hidden or cannot be represented by either top or side or also front view as we see before. Okay, so there is some techniques need to be used in order to understand how is the product or how is the object is looks like. So usually they use either the sectional view or some auxiliary views. Auxiliary views, that means you have like partial top view, partial side view, and so on. So you focus on the part which is not appear in the vertical view or is not appear in the side view and so on. So you focus on some part, so you enlarge this part or you represent this part by using specific view for this part, and we call it auxiliary view. So for the sectional view, it's like you cut the product or you cut the object in order to see how is the cross sectional of this object. What is inside? What is it like? I mean, is it like a cylinder inside, or is it a solid? Or so when you cut it, so you can know more about, or you can extract more information about the product. So for example, it's like you have a cutting plane here. You put the cutting plane on the middle of the cylinder, so you have such view here. So this view we call it cross or sectional view. So this sectional view, when you cut this cylinder, if this one for example is like if the top view for example of this one, it will be like a circle. So there is two circle if you have a top view, and also there is another, this will be represented by another circle. It's like one circle, two circle, three circle. This is only the top view that you have. But when you cut this by using cutting plane, you have more information about these parts, about the thickness, about the uh, how it looks inside, what's the diameter of this part, what is the diameter of the next part, what is the diameter of the third part, and so on. Okay, so more information will be extracted in the sectional view here. So it will be like this cutting plane, it will be perpendicular to this cylindrical or this object. When you represent it for cutting plane lines here, you need to represent it by using either one line or two perpendicular lines. So sometimes you need to use only one line. So you have one cutting plane, so it will be represented by one crossing line. But sometimes you need to represent it by two lines. So here sectional view is obtained by imagining that a portion of an object has been cut away to expose the internal lines and the internal surface of the object. So when you represent, you need to have like such, this is one cutting line plane, this is another cutting line plane. The angle here between these two lines is 90. They are perpendicular to each other. The arrow here, the small arrow with the, it shows the direction of the view. So it shows to up. That means it's like you cut it, and this represent the this one from the top view of this object. So the end of the cutting plane hairline are bent at 90 degrees. So this is the 90-degree that we have with the arrowhead to indicate the direction of the side. So this is the end of of this line or cutting plane line. Also, this is the cutting plane line for vertical. This is the cutting line for horizontal. Then they are two perpendicular. At the end here, we have with also with 90 degree. This indicate the direction. So it's up or down. It's indicate the direction of the view. So this we call it the sectional view. Sometimes you don't know how thick is this material, what inside this material, what is the type of maybe it's like for example for if you have a electric cable for example. So the electric cable for example, if you represent it is represented by cylinder inside cylinder, because sometimes you have the core of the cable and you have some other small wire which represent the ground or I mean for the cable here. So but if you cut this cable, so you can see what is the cross sectional of this cable, what is the material in between the layers of the cable themselves. So the end of the so as you can see here, so you have three type of sectional view. We have the full sectional view, and you have the half sectional view, and you have broken out or partial sectional or partial view. So the full sectional view here, obtained by passing cutting plane across the entire object. That means it's like the first one. So here you have the cutting plane. You go through all the object from the top surface until you reach to the end. So this will be represented by the cross sectional for this one. You are going, if you take the view from this side, it will looks like this one, because you make this cutting plane to cut the whole figure or the whole object from the top until the middle. Then the second type is the half sectional view. This can be obtained by two cutting planes. That means you have two cutting planes with the right angle. That means one on the middle, for example, from like we did here. This is one plane. There is another plane will be in this side. So it will be cut into two. It will represent like one cut. Since you have two perpendicular plane, so the object will be divided into 4 quarters. So you can see, you can take a sectional view for this part, sectional view for that part, sectional view for that part, sectional view for that part. Each one it has sectional view. So you can find for each half of the inner surface here. Also you can find for 1/4 or 3/4, because it will be like identical, or I mean, since for example if you have cylinder, you cut it for 4 sides. So I mean like this part similar to this part will be similar to that. So either you need to represent by 1/4 or 3/4 for the sectional view. The last type, which is the partial section here, or broken out. So that means you don't need to cut the whole object. You have some part of the object which is not clear in the I mean in the top view or in the side view or in the front view. So you just want to cut this part only. Other parts are clear in the object. So you need to focus on some part of the object. You cut this part and you make cross sectional for this part only, not for the whole cylinder, for example, like we did here. For example, here we make the whole sectional view for the whole part. But if I just cut a part of this ones, so just small part in this area, then I will take the cross sectional area for this part only. No need to make the cross sectional or the sectional view for the whole figure. You can see here, this is the difference between the three type of multiple sectional view. So the first one is the sectional view, which is the full section. That means you are going to cut it by using one plane to cut the whole object from the top to the bottom. Then you are going to represent the full object. In the second here, you are going to use two perpendicular plane. That means one plane will cut it horizontally, one plane will be vertical here. So you are going to take some half of sectional view. So you see the first, for example, is represented a half, so it will be like the same as this half, but this one will be like cut again on the other direction, like this direction. So you can be represented by it will be represented by this view. So you have more than one view. This is the view for the half. This is for the view for the quarter, for example. Because when you have two perpendicular plane, it will cut into 4 quarters. So if you want to see the quarter views, it will be like here. The half views will be like for this one. The third type, which is the broken out or partial sectional view. So in this case, we said we are only going to cut a part of the product. So this part only can be represented, not the whole. So I cut just small part from this object. So I want to see this object only. So we call it the broken out or partial sectional view. This is the first technique that used to show or to extract the view for some hidden part of the figure which is not clear in the three standard or three views, which is the front, top, and side. The second type of this technique is the auxiliary views. So auxiliary views, that means you are going to provide some views which is not, I mean, for a specific part which is not clear. So you just add extra views, either from the top, from the side, and so on, but you focus on some part of the products. For example, here, if this you have the surface of A, so this is the A surface here, and this is the A surface from the top, for example, from the side, from the front. You have thickness here for this part, you have also the top here, and you have a circle and so on, all showing there. But you want to show this part only. I mean, in the top view, for example, or in the front view, this part is not, it will not be appear. So how to make this appear, or how to represent this figure, this view, you need to use some auxiliary views to show this one. So this actually this surface that you want to show, like with sloping, with inclining, so it's not easy to be seen or to be represented in the normal views. For that, we need to have such auxiliary views. So as you can see here, we represent this part separately. We call it partial top view. So it's focused more on this part because this part is not appear in the three normal views that, for example. Also, we focus on this part for partial side view, so we can see how these hidden lines will be represented in this partial side view. In addition to this is partial auxiliary view for the both, either partial top or partial side view. So it's extra views as for the portion or a part of the object which is not clear in the main I mean in the main representation, like we see previously in the project here, that we see when we talk about the objection. I mean, for the first angle and this part, for example. Sometimes this part, it's not easy to be represented in the drawing. So it can be represented like straight, but in the real, it's not straight. It has some slope, it has some curve, and so on. So if it is a curve, which is a circle, so it's easy to represent. But if it's some curve, I mean, just at the angle here, it's not directly, it's not right angle. There is a small curve here. So sometimes this part is not easy to be represented. For that, they got to have such I mean auxiliary views, either for sectional views or some auxiliary views. Okay, here are some examples. I mean, sometimes you will be provided for like you have a lot of views here, and this is a views. So he says select correct orthographic view for the corresponding with the arrowhead of each pictorial view. So you have here different views, and he asked, what is this view here? It's represent which one of these figures. So I mean, you should imagine which of these figure can give you the view here. So is it A can be represented here? This is like isometric view, right? So for isometric view here, which is so showing from this place. So is it A? Is it B? Is it C? Is it D? Is it E? Is it F? Is it G, H, and so on? So you should understand how, if you press this cubic inside, so what will be the figure that you will have? So you will have, for example, one of the square inside, there is another square outside, and so on. So in this case, it will be like two squares or two rectangular, one inside other, in addition to one outside representation for this graph. So this view here will be reflective for this side here, because here you have one square, there is another square inside. There is no other has the two square, one inside one in this form. So this will be, for example, for the K. This is the view for this represent the K, for example. The second one here is it will be like this one. So you have from both sides, you have this rectangular on this side, you have this flat side, this is the vertical with the depth. On the other side also you have vertical with the depth, we have also the same. So now the second one, which represent for which of this figure is it, A, B, C, which view here is reflect the top view of this figure, for example. So it is represent for the figure M, for example, because we have one rectangular and you have another rectangular here, and you have also another rectangular. So M here, one for the you have for the middle one, but also the middle is not complete because on the down here is not solid part, so it will be represented by this dash. On the other side, you have one rectangular here and you have another rectangular, but the here, because it's not solid material, so it's represented by such dash points. For the third point here, which is N, so this N here, if you have the top also the same, you have one rectangular, one rectangular, one rectangular, but here the place that you have the solid part in the middle, there is a solid part, not like in this one here, there is no solid part here, and here there is a solid part. That means it's full. But in the second one, no, you can see here, this part, there is space here. It's not solid, but here there is a solid one. So the middle line or the middle rectangular, it has two lines, but the third one or the last one here, it has some hidden part, which is represent, I mean, dash lines, which represent the space here. This is just how to read the different views for isometric object or for an object, and for either for top view, for sectional, I mean side view, front view, and so on. So always you try to imagine how if you look at this object from the top, how if you look it from the front, how if you look at this object from the right side, what you can draw. So this also depends on your skills on imagination, how to redraw or to extract the view of the drawings that you have of the object that you have. Always you need to draw the thing that you see only, either from the top, from the side, or from the front side. So for the fourth one here, you have the J for the J object, which is here. So you can see here, this is the square, the cubic here. If you press, it will be represented by square on the corner. So the rest here we have square also. Then you have here some dash bar, which is represent this space. So this is the J. Another thing is how to reflect which this select the correct right side view. So that one on the top. So the right side view here, which one represent the right side view for this figure? Is it A, B, C, or D? So each one here represent for D. This is the right side view. You have the top side and you have the front side. What will be the right side? So you have the top, the front, and this will be the right side representation. Same here, you have top and front, and you will be asked for the which will be the the right side representation for this one. It will be B. So the B here represent the right side view of these two figures. That means it's as we said in the drawing. Usually we have the three views. You have the view for the top, the view for the right, for the front, and the view for the right. So sometimes, if you already have, this only to help you to you can imagine what will be the new or the missing view in the figure. So here, missing views, complete the views here. For example, here you have the top view is not drawn, but you have only the front and you have the side view. So how you are going to draw or to represent the top view of this figure? Imagine this will be the right side view of your object, and this will be the front view of your object. How you can reflect or how you can represent the view of your top of this object. So you just, this will be the view. So from the top, it will be like three rectangular here. One of these rectangular is higher than the other 2 because you can see here this is the increment. This is the different or the height of this rectangular is placed here. The second rectangular is smaller, and from this side here the thickness of this rectangular is less. For example, the thickness I mean 2 square and this 2 square, I mean the thickness of this from the front view is the same, but here this will be 4 squares. 1 2 3 4 5, these 5 squares, these 2 and these 2. So that means this part will be a little bit higher than the other 2 parts. If you come here to the side view also, the higher 2 parts, the other 2 parts is like there is one down, one up. That means also these 2 are not at the same level. There is one at the bottom and the other is higher than by 2 squares. So this is how to try to read the existing figure to find the missing views. Usually all these view will be provided for, for the figure that you want to write the program. But sometimes this only to help how to read these figures and how to understand how to extract the information from the given views of the figures. Same here, we have the top view and we have the front view. This is the top, this is the front, and he asked about the side view for this figure. So from the top, if you look at it, there is something, some part is like here you have hidden line. So hidden line, that means there is no solid part under this part. From the side here, you have 3 rectangular, one rectangular here or square, or 1 square here, 1 square there. So but the level of all is the same. Also the level of all here looks the same. So here it will be appear only more on the hidden bar that you have in this side. It will be represented in this part. So please try to practice. I already upload one file in Kalam. I will release after the class. Okay. So there are a lot of exercise about how to read these figures, either to find the dimensions, to extract the view, to know which is the side view, the top view, the front view, and so on. So you need to go through and practice, and don't try to omit the answer. I gave the exercise with the answer actually, but I want you to try to solve first. Or at least understand how this value is comes. So don't just say, oh, the answer already there, no need to go through. No, I want you to go through, try to do the to solve this exercise without looking at the answer that is provided, okay? Or understand how this answer is comes. The next part, is it okay until here for the views type? Hello.
Hello, sir.
How are you?
This more practice maybe understandable.
Yes, for that I told you I gave more exercise. You can go through. Okay, I will ask. I want to ask you, but I want to finish one part first. I want to go one by one. Okay. Okay, for the dimensioning system here, as we said here, it's okay to know the view, to extract the view, but the most important, not only the view, the most important is the dimensions. What is the length here? What is the height? What is the depth, and so on. So the dimension is more, the view is the first, at least you have the view, then you need to know what is the dimension of these objects, of these lines. Okay, so the dimension here is, there is 4 different systems for dimensioning used: fractional inch, decimal inch, dual dimensional dimensioning, and also SI matrix. The SI matrix, the normal that we use, millimeter, for example. So just if we say they are the most important, there are 2 types or 2 systems. One is the SI matrix, which is the millimeter, and the other one is the inch, which is use the inch in their measurement. So usually this engineering drawing are represented either by inch or millimeter. So if they use the inch system that they use in US, so they are going to use it in inch, either in the fractional or decimal inch, or for the SI matrix, the dimension will be represented by millimeter. Okay, usually the dimension here is a numerical value expressed to with the unit. So for example, if I say this is 45, I have to know this is 45, for example, millimeter or 45 inch. So this we call it the dimension. And the dimension for the figure, when we represent it in the engineering drawing, it will be represented by number with line with two arrow here at the end, and these two arrow are also with two lines. These two lines for projection lines. That means the length from this point to that point is 45. No, it's not acceptable just to put like this one, just line. You must identify this line until which point should be like this until this point. This line until this point to until this point. I mean like this one, so it will be like from this point. This will be the dimensions. So usually the dimensions are represented by this line with the number that show the values in decimal in the decimal. If the number is integer, so it's like a number. If there is some numbers, I mean point, 0.1, 0.2, 0.10 millimeter or inch and so on, so it will be there. But usually also there is some, you should have this small space. This small space, that means it shows that this product is not continue here. We need to represent the space because this is not continuous. It's not continuous, so it's just a dimension line. It's not a line from the as a part of the our figure or our object. So you can see here there is space in between the line or the projection line and the object, and there is a line here or space between the line and the object. So this is the I mean the dimension, which is 45, for example. So the most common type of the dimension, usually, I mean the dimension type, as we said, is the US standard, which use inch, or the international system units, which is SI, which is used millimeter. So all the dimension either in inch or in millimeter, and it should be like consistent. It's not some of the figure has inch, some has inch. No, either all millimeter or all inch. Also, if the value is small, which is less than 0, you need to add point. So when you write the code for the machine, you should indicate this one, 0.5, 0.23, so it cannot be like 0.23. Must be have that point here. Also, as we said, the line is not touch the object, so it's not confusing for those who will produce the product. So they think this line is not dimensional line, it is an part of the object borders. There are different type of dimensioning. So I mean how to represent the dimension on the figures or on the drawings. So this the type they call it the chain dimensioning. So the chain dimensioning, you can see here, this is a dimension, this is another dimension, another dimension. It's like a chain, so it's like continuous. There is no part without the dimensions. Start one by one until the end. So this we call it the chain dimensioning of the system, I mean of the figure. So this type of dimensioning will not be affected by the accumulation of the tolerance, because if the tolerance is 0.05, for example, we are not going to say 0.05, 0.05 plus 0.05 now. The whole tolerance will be 0.05, for example. This type we call it the combined dimensioning. So the combined dimensioning, so for example, you can see here, this is small dimension, and here this dimension is not there, but we have the bigger one. So this combined this part and this part. So we call it the combined dimension. It's used to indicate more than one part, or the length or the dimension of more than one part. Dimensioning for holes usually are represented if you have holes on the objects, so you have some circles, holes, and so on the object. So you can define the dimension for object in addition to mention the way for radius and diameter. For example, we can also indicate the dimension in terms of the axis or coordinates. So we can say, for example, hole A1 is located at 125 with this, for example, with this diameter or with this radius and so on. So we need to highlight the coordinates. So coordinates will identify, or will define the position of the hole on the object, and the value or the radius or diameter will define how big is this circle or this hole. So we start now with this some examples that we help to read some of the dimensions. So for example here, what is the dimension for this spacer block? What is the dimension of A here? You can see in the figure here, it is A. A is placed between these two lines. So what will be the value of A according to this figure? We are going to see examples here. Then I'm going to ask you about similar things, okay? So I hope we still have time to do some exercise, okay? So this the dimension of A according to this place. You can see here, is it 0.62? Is it the same?
Yeah.
So it is 0.62 from this point, for example. So this is A is 0.62. For J here, for the value of J, where is J in the graph? This is J, for example. So you want to know the value of J here, start from this point, which is 0.66 until 0.64. So it will be 0.66 plus 0.64, it will be 1.3, for example. So this is how we can calculate the dimensions from the views, from the different views. You have three views here, you have top and you have side, you have front views. So from different views, you can know what is the dimension of this object. These dimensions will be fed to the CNC machine in order to do cutting. For example, if I said this length is 2 millimeters, so the machine should make like turning or milling for this up to 2 millimeter, for example. If I want to make it like this length is 2, so the header or the spindle will move until here without cut anything. Then it come at this point, he do the cut or do milling and so on. So these coordinates or this dimension will be fed in the form of coordinates to the machine, so the machine can perform the task. So for the J here, for example, the value of J is represent the thickness of this from the line, the black line and the dash line here. So how to find this thickness here? We can find from the value, from two different values, from the 0.8, for example, here, and the 0.08 to 0.92. So the 0.92 here represent the dash lines. The 0.82 represent the straight lines. So the difference will be 0.1. So this will be the value of J. Another calculation for the dimension here, for example, what is the height dimension, what is the width, what is the length, and so on. So depends on, you can see here from the isometric view. So you can see what is the depth here, what is the width, what is the height. This will be the dimensions. So from the front view, for example, you are going to find the width here. You may find the width from the front view. You may find the width from the top view. You also you can make you may find the depth from the either from the right side view or also from the if it is in the right side view. If not in the right side view, you can find from the top. You can find from the from the side front view. So it depends on how these dimensions are represented in the figure. So what is the height dimension here? So the height is here, where you can find the height for your object. You can find the height of your object either on the value of the A, is it the value of A plus value of E here, which is 1.1. Is it the 1.1 here is the height, or you can see here the value of G is the value of the height because it indicates the highest value of at this point. So this is the highest value at this point. So here, this one is 1.1, but also you still have 1.3 is here. So since this part is the highest, not this one, so you can see from this view here, this is the highest one, this is the down. So the difference from this point until the ground is 1.3. So this represents the height of your figure. You can you take it, see, even though the height, it looks like you can take it from the front view, but it's easy to take it from the right side view, because also the right side view, it will push this rectangular inside this one, this will be pushed inside that one, and the total will be the height for this project or object.